Hey everyone, and welcome back to the Deep Dive. Today we are diving deep into LLMs, large language models. You sent us LLM with Python.pdf, and wow, this guide is amazing. It's like a roadmap to building LLMs with Python. We'll explore how LLMs went from, basic models to GPT-3 and even beyond, and how these models are changing everything. From healthcare to entertainment, LLMs are everywhere. And of course, we'll break down how Python plays a role in all this, including, the libraries that are must-knows if you want to develop LLMs. So joining me to help make sense of all this, we have our expert, who's ready to break down all these complex topics.
I think what's really cool about LLMs is it's not just that they understand human language, but they can generate it too, almost like they're learning to think and speak like we do, which is kind of freaky, but also really cool.
Okay, so this guide defines LLMs as these deep learning models trained on huge amounts of text data. What's the goal? Like, what are we trying to achieve here?
Well, the goal is to create a model that can predict the next word in a sentence, which sounds simple, but it's the foundation for some pretty incredible stuff. Think about like a tool that can help you write better, faster, or even come up with creative content like on demand.
Yeah, that is powerful. That's what I'm talking about. And this guide talks about, how LLMs have evolved, starting with GPT, then GPT-2, then the big jump to GPT-3, and now we're even seeing GPT-4. It's like each version just gets more and more powerful exponentially.
It really is mind-blowing. And what's really interesting is that these advancements aren't just stuck in research labs. They're actually being used in the tools and technologies we use every day. Think about chatbots that can actually hold natural conversations or language translation services that are crazy accurate, and even content creation tools that help writers produce really high-quality work.
I know, I see them everywhere I look these days. And speaking of tools, we got to talk about Python, because this guide makes it very clear that Python is the HE language when it comes to LLM development. So what is it about Python that makes it so special in this field?
I think you hit the nail on the head there. Python is essential for anyone working with LLMs. And why is that? Well, first of all, Python is known for being simple and readable, which is a huge plus when you're dealing with these really complex models and algorithms. But on top of that, Python has this amazing community of developers and just this massive ecosystem of libraries. They're specifically designed for LLM development.
Okay, so the guide actually mentions a few of these libraries, like Transformers, TensorFlow, PyTorch, and Spacey. Can you give us like a quick breakdown of each one, like what's each one good for?
Absolutely. Think of these libraries as your toolkit when you're building and working with LLMs. So Transformers, that's your go-to for working with pre-trained models, which are basically like ready-made LLMs that you can fine-tune for specific tasks. And then you have TensorFlow and PyTorch. These are the big, powerful frameworks for actually building and training LLMs from scratch. They provide the building blocks, the computational muscle that you need to create these complex models. And then last but not least, there's Spacey. Spacey is an awesome library for processing and analyzing text data, which is like the foundation of any LLM. It helps you, clean and prepare and understand the text data that your LLM is going to learn from.
So we've got the tools, but now we need to look at the ideas behind how LLMs actually work. The guide mentions some important NLP things like, tokenization and embeddings. Can you break those down for us, make those a little easier to understand?
Sure, yeah, those are like the building blocks of how these models work. Imagine you've got a sentence and you want an LLM to understand it, right? The first step is tokenization, which is basically just breaking down that sentence into individual words, or sometimes even parts of words. Like, imagine you're taking apart a puzzle and you can analyze each piece.
So we're taking the language and like breaking it into its smallest meaningful units. What happens next?
Well, once you have your tokens, right, you need to represent them in a way that a computer can actually understand. And that's where embeddings come in. Embeddings are like giving each word a unique numerical code that captures its meaning and how it relates to other words. So imagine you have the word like king. Its embedding would capture, not just the literal meaning of king, but also its relationship to other concepts like royalty, power, masculinity.
It's amazing how they can capture all those nuances of language. But there's got to be more to it than just understanding individual words, right?
Yeah.
The guide also talks about something called the attention mechanism. What is that all about?
You're right. Understanding individual words is just the start. The attention mechanism is what allows LLMs to understand, the relationships between words in a sentence, or even, across longer pieces of text. It's like giving the LLM the ability to focus on the most important parts of the text, just like we do when we're reading. Like if you're reading a news article, you'll probably pay more attention to the headline in the first few paragraphs, right, to get the main idea of the story. The attention mechanism lets LLMs do something similar.
So it's like They're figuring out what to prioritize and understanding the context of each word. Okay, now that makes sense. Now, the guide also mentions pre-training, fine-tuning, and transfer learning. Can you explain those concepts for us?
Of course,
Yeah.
yeah. Think of it like this. Imagine you're teaching someone to play a musical instrument. You'd probably start by, giving them some basic music theory lessons. Maybe have them practice like scales and simple melodies, right? That's kind of like pre-training. So in LLMs, we pre-train these models on a massive amount of text data. And this gives them a broad understanding of language and how it works.
So it's like giving the LLM a solid foundation in language. But then what about fine-tuning?
Fine-tuning is where we take that pre-trained model and make it more specialized. It's like taking someone who's learned the basics of music and then teaching them to play like a specific instrument or a specific genre. We fine-tune an LLM by training it on a more specific data set that's related to the task that we want it to perform. So for example, if you want your LLM to be really good at understanding like medical text,
Hmm.
you might fine-tune it on a data set of, medical journals and research papers.
So it's like taking a general LLM and turning it into like a domain expert. Hmm. But what about transfer learning?
Transfer learning is kind of like taking the skills you've learned in one area and applying them to something new. So in the world of LLMs, we can take a model that's been pre-trained on like a massive data set, all of Wikipedia, for example, and then fine-tune it for a very specific task using a much smaller, more focused data set. And this saves us a lot of time and resources because we don't have to train a model from scratch on that new task.
That sounds incredibly efficient. So we've talked about what LMs are, how they've evolved, the key concepts, the essential Python tools. And one thing that's clear is that data is like the fuel that powers these models. And this guide dives into, the importance of data preparation and talks about sourcing the data, annotating, and labeling it. So where do we even begin with all of this?
Data really is the foundation of any LLM. It's what they learn from, and it's ultimately what determines how well they perform. Think of it this way. If you want to train an LLM to understand and generate human language, you need to feed it a huge amount of high-quality text data. That reflects all those nuances and complexities of how we communicate.
So how do we go about sourcing that data? Like what options do we have?
Well, there are two main categories of data sources, public and private. Public data sets are like, these vast libraries of information that are available to anyone. A great example that the guide actually mentions is the IMDb movie reviews data set, which contains, thousands of movie reviews that have been labeled as either positive or negative. These public data sets are awesome for like experimenting and getting started with LLM development.
Okay, that makes sense. But what about private data sets?
Private data sets are those that are owned by like specific organizations, and they often contain, sensitive information that needs to be protected. So think about things like medical records, financial transactions, even proprietary code. Access to these data sets is usually restricted, and there are all these regulations around how that data can be used.
So sourcing the right data is the first step, but then we have this whole process of annotating and labeling it, right?
That's right. Annotation and labeling are about adding meaning and context to the data so that the LLM can understand it. So imagine you're training an LLM to understand like customer sentiment from online reviews. You would need to label each review as, positive, negative, or neutral. This labeling process basically teaches the LLM how to interpret and categorize different types of language.
So like we're giving the LLM a set of rules for understanding like the subtle ways that humans express themselves. This all makes perfect sense. But I'm kind of curious about the practical side of things now. So we have the data, we've prepared it. Now what? Like how do we actually build and train an LLM?
This is where things get really exciting. So first, we need the right tools for the job, right? We're talking about powerful hardware, things like GPUs, which are specialized processors designed to handle the intense calculations involved in training these massive models. And of course, we need our trusty software, Python's CUDA platform for interacting with those GPUs, and our chosen deep learning framework like TensorFlow or PyTorch.
Sounds like we're getting ready for a major undertaking here. What about the actual model itself? The guide mentions different model architectures like Transformer, RNN-LSTM, and CNN. Are those like the blueprints for building the LLM?
You got it. Choosing the right architecture is crucial because it determines how the LLM is going to process and learn from the data. It's like choosing the right foundation for a building. Each architecture has its strengths and weaknesses, and the best choice depends on the specific task you're trying to achieve. So, for example, transformer architectures, those are the ones used in like GPT. They're really good at handling long sequences of text and capturing those complex relationships between words. RNNs and LSTMs, on the other hand, those are better at processing data that comes in a sequence, like time series data or even speech. And
Mhm.
CNNs are often used for image and video processing, but they can also be adapted for text-based tasks.
So we have to think carefully about the specific task when we're selecting an architecture. Once we have the architecture, do we build the model from scratch, or are there, like,
Hmm.
shortcuts?
Well, we could build a model from scratch, which would give us, total control, but it requires a ton of data, a ton of computing power, and a lot of time. Or we can be smart and leverage the power of pre-trained models, which are, models that have already been trained on massive data sets and are ready for us to use as a starting point. And then we can fine-tune them for our specific task using a much smaller, more targeted data set.
That sounds a lot more manageable.
It definitely is. It's like having a head start in a race. And then comes the actual training, which is where things get really interesting. We have two main approaches, supervised and unsupervised learning. So in supervised learning, we feed the model labeled data where we know the desired outputs. So for example, if we're building an email spam filter, we would train the model on a data set of emails that have already been labeled as spam or not spam. The model learns to identify the patterns that distinguish spam from legitimate emails.
So it's like we're teaching by example, showing it what's right and wrong. What about unsupervised learning?
Unsupervised learning is a bit more exploratory. We give the model unlabeled data and let it try to find patterns and relationships on its own. Think about like topic modeling. You could give the model a collection of, say, news articles and let it figure out what the main topics are that are being
Without
discussed.
giving it a puzzle and letting it figure out how the pieces fit together.
Exactly. And as with any complex task, there are going to be challenges we need to watch out for during training. Overfitting is a common one. It's like when a student memorizes the answers for a test but doesn't really understand the material. The model performs really well on the training data, but then it fails to generalize to new data that it hasn't seen before. And then you have underfitting, which is basically the opposite. The model is just too simple to capture the complexity of the data. It's like trying to fit a square peg in a round hole. We have to find the right balance, to create a model that can learn effectively and actually perform well in the real world.
It sounds like building and training an LLM is kind of a delicate balancing act.
Hmm.
We have to carefully consider the data, the architecture, the training approach, and look out for all these potential pitfalls. But this is really just the beginning, right? Like, we've built our LLM, we've trained it, but what happens next?
You're exactly right. Building and training is just the first step. The journey doesn't end there. Now we've got to make sure this LLM actually does what it's supposed to do. Time to put it to the test and see what it can really do.
So it's evaluation time. This guide mentions all kinds of metrics like accuracy, precision, recall, even the F1 score. Well, what are all these about?
Think of these metrics like a report card for your LLM. They tell us how well it's performing on a particular task. Accuracy gives us a broad overview. It shows us the percentage of predictions that the model gets right overall. But sometimes we need to dig a little deeper.
Yeah, accuracy alone might not tell the whole story. What about precision?
Precision focuses on how accurate our positive predictions are. Let's say, for example, we're using our LLM to identify spam emails. Precision would tell us, out of all the emails the model flagged as spam, how many actually were spam. It's about minimizing those false positives, making sure we're not flagging legitimate emails as spam.
And recall is about making sure we don't miss any of the important stuff.
Exactly. Going back to our spam filter example, recall measures how well the model is able to catch all the actual spam emails. It's about making sure that none of the bad stuff slips through the cracks. And then the F1 score, that basically combines precision and recall into a single score, giving us a more balanced view of the model's overall performance.
So we've evaluated our model, and let's say it's not quite performing as well as we hoped. What can we do to improve it?
Well, that's where fine-tuning comes in. We can take our pre-trained LLM, which already has a solid foundation in language, right? And train it further on a more specific data set, one that's really tailored to the task we want it to perform. It's like giving our LLM specialized training to become a real expert in a particular field.
I like that this guide has a great example of fine-tuning a general LLM on a data set of medical records, and that made it way better at understanding and even generating medical text.
It's a really powerful technique. And there's another interesting concept called knowledge distillation. It's kind of like taking all the knowledge from a more experienced teacher and passing it on to a younger student. So we train a smaller, simpler model to mimic the behavior of a larger, more complex LLM.
Why would we want to do that?
Well, smaller models are generally faster and more efficient, which is super important when you're thinking about real-world applications, especially on devices that might have limited resources. Imagine trying to run a super sophisticated LLM smoothly on a smartphone, for example. That's where knowledge distillation comes in.
Makes sense. So we've built our LLM, trained it, evaluated it, and even fine-tuned it for optimal performance. It sounds like we're ready to set it free and let it loose on the world. What happens during deployment?
Deployment is basically the process of taking our LLM from, the development stage and putting it into the real world, where it can actually be used to like solve problems and create value. So we need to think about, where it's going to live, how it's going to interact with other systems, and how we're going to make sure it runs smoothly and efficiently.
So where do LLMs usually live?
We have a few options. We can deploy it on the cloud using services like AWS SageMaker, which provide all the infrastructure and tools we need to like manage and scale our LLM, or we could deploy it on premise, meaning on our own servers, if we need more control over the environment or have, strict security requirements.
Okay, and this guide actually shows us how to use Flask, which is a Python web framework, to create an API for our LLM. What are the advantages of using an API?
Well, APIs are kind of like doorways, right? They allow other applications to communicate with our LLM. So imagine you're building a chatbot that uses our LLM to like understand and respond to user queries. That chatbot would communicate with the LLM through its API, sending requests and receiving responses.
So it's like giving other developers a way to easily tap into the amazing language capabilities of our LLM.
Exactly. And what if our LLM becomes super popular? Like it's handling a ton of requests all at
Can they
once.
handle all that pressure?
That's where scaling comes in. We can use load balancing to distribute those requests across multiple instances of our LLM, kind of like having a team of, super skilled translators all working together to handle a surge in translation requests.
So that way no single instance gets overwhelmed.
Precisely. We also want to make sure that inference is fast, meaning how quickly our LLM can actually process and respond to requests. This is especially important for like real-time applications like chatbots or voice assistants, where users expect instant responses. There are techniques like model quantization, which basically slims down the model, and caching, which stores frequently used results. Those can significantly speed up inference.
It's incredible how much goes into deploying and scaling these models effectively.
It's a really interesting challenge. And, once our LLM is out in the wild, we can't just forget about it. We need to keep a close eye on it. We have to continuously monitor its performance to make sure it's still running smoothly and efficiently.
What are some of the things we should be monitoring?
Well, we definitely want to keep track of things like, response times, error rates, and how much resources it's using. But we also need to be on the lookout for something called model drift, which is basically when the model's performance starts to decline over time as the data it was trained on becomes less relevant. It's kind of like needing a refresher course in a language after not speaking it for a while.
So we might need to retrain our LLM with fresh data to keep it like sharp and up to date.
Exactly. And it's not just about technical performance. We also have to consider the ethical implications of using LLMs, right? These are incredibly powerful tools, and it's crucial that we use them in a way that benefits everyone and doesn't create harm or perpetuate biases.
This guide really emphasizes the importance of like proper documentation, setting up accountability measures, and even developing clear ethical guidelines for LLM use.
Absolutely. Those are all excellent practices. LLMs are still a relatively new technology, and we're constantly learning more about their capabilities and potential impact. It's important to proceed with caution and really think things through, making sure that these powerful tools are ultimately used for good.
This guide is full of such great practical advice and real-world examples. I'm personally really intrigued by the idea of building a chatbot using Python and LLMs. Imagine having a virtual assistant that can understand your questions and respond in a natural conversational way.
The possibilities really are endless. LLMs are already being used to, generate realistic dialogue for chatbots, write different kinds of creative content, even compose music. We're just scratching the surface of what these models can do.
Okay, so we've covered the basics of LLMs, the intricacies of deployment and scaling. We even touched upon the ethical considerations. But this guide also hints at some more advanced techniques that honestly make my head spin a little bit. Things like distributed training or exploring architectures beyond transformers. We're ready to go there?
Absolutely. The world of LLMs is constantly evolving. There's always more to learn. Let's push our understanding even further and see what these cutting-edge techniques are all about. It's like taking our LLMs to the next level.
Yeah, those sound really interesting, like we're building on what the LLM already knows.
Exactly. Imagine we've got an LLM that's learned a ton about language from reading, like tons and tons of text. We can then take that model and train it further on something more specific, like, legal documents or something.
So it's like fast-tracking its expertise in a certain area.
Exactly. We're using what it's learned from one task and applying it to a different but related task. It saves a bunch of time and resources compared to starting from scratch with a brand new model. And domain adaptation is similar. It's where we adapt our LLM to a specific domain, like medicine or finance.
Like giving it a specialized internship.
Uh-huh. I like that. Now, training these massive LLMs takes some serious computing power. And the guide mentions some ways to optimize things and make the training process more efficient.
Yeah, efficiency is key when you're dealing with these huge models.
Yeah.
What are some of the strategies?
Well, one technique is called mixed precision training. It's kind of like finding a shortcut, but without sacrificing the quality of the results. It basically reduces how much memory we need and speeds up the training without really affecting the accuracy.
So we're streamlining the process without, like, compromising the quality.
Exactly. And then there's this thing called distributed training, which is a bit more involved. It lets us split up the training process across multiple machines. So it's like having a team of computers working together to train this one giant model. This is really important when you have these massive data sets and these really complex models.
It's like creating a supercomputer by connecting multiple machines.
Right. So we've optimized the training, but now what about actually deploying the LLM? How do we make sure it runs efficiently in a real-world setting?
I'm all ears.
Well, the guide talks about techniques like model quantization and knowledge distillation, so model quantization. That basically shrinks the model down, makes it smaller and faster, but it doesn't lose too much accuracy. It's like compressing a file but keeping all the important information.
So it's more compact, more agile.
Right. And knowledge distillation, that's like imagine you have a really skilled teacher
Mm.
and you want to train a student to do the same task, but with fewer resources. So you train a smaller, more efficient model to copy the behavior of a larger, more complex one. It's great for using on devices that have limited resources, like smartphones.
So it's like a more portable version, but still really intelligent.
Exactly. It's about finding that balance between performance and efficiency. But wait, there's more. The guide also mentions these things called multimodal models, which are pretty amazing.
Multimodal models. What are those?
These models go beyond just text. They can handle different types of data, like text, images, even audio. It opens up all these crazy possibilities. Imagine an LLM that can understand a picture and write a caption that perfectly captures what's happening, or a model that can analyze medical images and text reports at the same time to give a more accurate diagnosis.
That's wild. It sounds like LLMs are becoming more and more versatile and integrated into our lives in new ways.
Absolutely. And the research is moving so fast. Researchers are even looking at new architectures beyond transformers, which have been the big thing in recent years.
So transformers might not be the end of the line.
Well, transformers have definitely revolutionized the field. But exploring these other architectures, like graph neural networks or recurrent neural networks, could lead to even more breakthroughs, especially for tasks that need different types of data or different ways of thinking. The field is constantly changing, and that's what makes it so exciting.
It's crazy to think about what the future holds for LLMs.
I know, right? Imagine things like personalized education that adapts to how you learn best, AI tools that can help you write stories or compose music, or even breakthroughs in healthcare, where models can help doctors diagnose and treat diseases. The potential is limitless.
It really does feel like we're at the start of a language-powered revolution.
We are. But as we keep developing and using these powerful tools, we have to do it responsibly. We need to make sure they're used for good, that they're fair and unbiased, and that they benefit everyone.
It's been an amazing journey exploring LLMs with you. We've covered everything from the basics to the latest advancements, and it's clear that this field is just exploding. To our listener, I encourage you to keep learning, keep exploring, and hey, maybe even build something amazing with these incredible tools. You never know what breakthroughs you might achieve. That's a wrap for this deep dive into the world of LLMs with Python. Until next time, keep learning, keep asking questions, and keep diving deep.